Hi guys, in the last video we introduced the quadratic formula and we used the quadratic formula to solve a quadratic equation, right? Now while we were actually looking at the quadratic formula, I talked about the quantity inside the radical, and that quantity is called the discriminant. Now guys, that is sometimes very important when we are working with some specific type of problems. And I'm going to show you some examples, what I actually mean by those specific type of problems. So sometimes we don't really want to find the solutions. Rather, the problem says, how many solutions does this equation have? So we already know that a quadratic equation could have two solutions, one real solution or no real solution, right? So in order to save us some time and get that job done quickly, we don't want to use the whole method and try to solve everything. We just want to focus on the discriminant piece. And then based on that, we can say whether there's two real solutions, one real solution, or no real solution. So here I'm going to kind of draw a table and I'm going to write some rules and which you can actually understand. And I will also show you then examples, okay, using those rules. So there's three possible scenarios that can happen here. So we'll start with the first one and then we'll talk about the other two. So guys, here, let me make three columns here. So here, let's say we have the discriminant, which we like to call as D, and then here let's say number of solutions, and then here I also want you to look at the graphs. Okay, you already have seen graphs when I in my introductory video on quadratic functions, and you will see probably the same thing here as well. So guys, you know from my last video that the discriminant, before we actually start with the discriminant, let us recall the quadratic formula. Guys, the quadratic formula looks like this: negative b plus minus radical b square minus 4ac divided by 2a, right? And the discriminant is the quantity inside the radical, which is b square minus 4ac. So if the discriminant b square minus 4ac, if it is greater than 0, which means if it is a positive quantity, then how many solutions are we going to get? Guys, it's not too complicated to actually see that from the quadratic formula. So if the discriminant, which is this piece, if that is greater than 0, then the radical of that is going to be a number, right? Is going to be a real number. So if this quantity is a real number, then we have minus b plus minus that. So we'll have two real solutions because we have a valid real number for the radical of a real number. Okay? So we're going to get two real solutions. Okay. Guys, it's not too difficult to see that because you have the quadratic formula in front of you. This radical of this quantity, which is a positive quantity, is going to give you a positive quantity, and then you have the rest of it with a plus and minus, so you will have two real solutions. Okay, you are guaranteed to have two real solutions. Second case is if I have b square minus 4ac equals to 0, right? There could be at the end of the day, this is b square minus 4ac is we are going to end up with a number. So what are the three possible scenarios for this number? One, it could be greater than 0, a positive number, or it could be actually 0. Or then the third one would be, it could be a negative number, right? Now, if it is equal to 0, guys, look at the quadratic formula again. If this whole quantity inside the radical is 0, then you take the radical of 0. Radical of 0 is still 0. What does that mean? That means this whole quantity basically just goes away, it just vanishes. And you're only left with, in that case, you're only left with negative b over 2a. The plus and minus does not mean anything because your plus or minus, there's a plus and minus of 0. Adding 0 to something or subtracting 0 from something does not change that quantity, right? So you're only going to end up with something like negative b over 2a. That means how many solutions do we have? In this case, we're only going to get one real solution. Just one real solution. One real solution. And then the third one is if you have this quantity, the discriminant less than 0 or a negative, okay? So here we're looking at all the positive numbers. Here we are looking at the negative numbers, right? And this is like the 0. And if it is less than 0, again, we are going to look at the quadratic formula. If this quantity is less than 0, that means it's a negative quantity. And we are trying to find the square root of a negative quantity. Wait a minute. Well, if we are looking in the real number system or basically real number, line, we cannot find the square root of a negative number, right? In order to do the square root of negative numbers, we have to extend our real number system to a complex number system, which, I mean, I have uploaded some videos on complex numbers, and I'm going to upload more videos on complex numbers. But right now, if we are only thinking these solutions in terms of real solutions, then basically we cannot simplify radical of a negative number in terms of the real solutions, right? So what does that mean? That means in this case, we have no real solution. And guys, this takes us back to the introductory video where we looked at the three possible scenarios when the graph touches the x-axis at 2 points, 2 solutions, 1 point, 1 solution, and if it does not touch at all, that means it has no real solutions. And I'm going to quickly draw some of those graphs here. So you could have, for 2 real solutions, you can have a graph which looks something like this, and you can clearly see that it crosses or it touches the x-axis at 2 points. And we also know at the same time that a graph of a quadratic function can open up, or it can also like open down, right? So you can have something like this, and we still have 2 points. I mean, we have this graph touching or crossing the x-axis at 2 points, so 2 solutions. That is the first case. The second case is only 1 real solution. That means the graph only touches the x-axis at, let's say, looks like this. So only at 1 point. The other one could be when the graph opens up, it could look like, let's say it looks like this. The key is here that it only touches or it crosses that, it touches the x-axis at only 1 point. And then no real solution obviously means that it does not touch the x-axis at all. So if it opens up, it could be, let's say, like this. It is not touching the x-axis at all, no real solution, or it could look like this. Again, not touching the x-axis at all. Okay, guys, these are the 3 possible values for the discriminant, and based on those values, one can say whether there is 2 solutions, 1 real solution, 2 real solutions, 1 real solution, or no real solution. So this comes handy when you are trying to figure out only how many solutions do we have rather than actually finding the solutions. Okay, so when you are asked to find the number of solutions, rely on the discriminant and don't try to actually solve the whole thing. Okay, that will save you time. And if you're trying to do these things on a standardized test, guys, we want to make sure that we are not using too much time. So this would be a good strategy to save some time. Okay, so in the next video, I'm going to actually take up an example, and we're going to look at how we can use the discriminant to answer some, like how many solutions one can find in for a particular quadratic function. Okay, thank you.